Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module, next problem number 8, fluid mechanics. So, as usual, first we come to our statement. Estimate the total mass of the Earth's atmosphere. Hint, or in other words, given data which is a constant value and can also be found from concerned tables given at the end of a textbook, usually in appendix form. Okay. Hint given within bracket, the radius of the earth is 6.37 into 10 raised to the power 6 meter. This is a universal constant. Okay, this is a constant value. Okay, even if it is not given as a hint within bracket, we can solve this problem. Okay, and atmospheric pressure at surface is 1.013 into 10 raised to the power 5 Pascal. This is also a constant and can be found from table of constants, usually given in appendix at the end of a textbook of physics. Okay, now we come towards the solution. Dear students, as in our previous modules on fluid mechanics, we are starting with the same beginning. Okay, we know that pressure P in a fluid is the force per unit area exerted by the fluid on a surface. Pressure is defined as force over area. In the SI system, pressure has units of newtons per square meter. Okay, that is capital N over small m square, and 1 Newton per meter square is equal to 1 Pascal, abbreviated as PA. Okay. To this extent, this portion of this solution has been repeated in our previous several modules. Okay, now we move further which may not be repeated in our previous modules. Okay, moreover, area of a circle is equal to pi r square and surface area of a sphere is equal to 4 pi r square. Okay, dear students, actually formula for calculation of circle for different geometrical shapes is different. Okay, similarly formula for calculation of volume is different for different geometrical shapes. Okay, so both these formula are our concerned, and the second one will be used in this problem. Okay, using 1 Pascal equal to 1 Newton per meter square equivalently equal to 1 kilogram per meter second square equivalently equal to 1 joule per meter cube. Okay, to this extent we have repeated this definition many times. Okay, here third equivalent value is not relevant in this problem, only second last equivalent value will be used. Okay, that is 1 Pascal equal to 1 Newton per meter square or 1 kg per meter second square. Okay, further, F equal to mg in accordance with Newton's second law of motion, F equal to mg. A is equal to 4 pi r square, because, dear students, we are required Earth's atmosphere surface area of a sphere 4 pi r square, area of a circle simply pi r square. Okay, here we will use a equal to 4 pi r square, r equal to 6.37 into 10 raised to the power 6 meter. This is given in this problem statement as a hint within bracket. But even if it is not given, we can find this value from table of constants given in appendix at the end of a textbook of physics. Okay, similarly value of g is also a constant value. G is equal to 9.8 meter per second square, we know, and it is not given in the statement. It is a constant value. Similarly, pi is equal to 3.14, 22 by 7, 20, 22 by 7 decimal representation of pi goes endlessly. It is a non-terminating, non-repeating expression. It goes endlessly. Okay. Similarly, pressure is equal to 1.013 into 10 raised to the power 5 Pascal. It is given in this statement as a hint within bracket. Even if this hint is not given, we can find this value from table of constants given in appendix at the end of a textbook. Okay, okay. Using all these values in equation number 1. Equation number 1, this equation number 1. Okay. Using all these values in equation number 1, we get, okay, in place of P, we have used the value of P given in the statement is equal to F over mg, F over A. In place of F, we have used mg. In place of A, we have used 4 pi r square. Next, we have done nothing. We have just simplified these values. Okay, we do not go in detail of these simplifications. Okay, it is quite simple. So, however, I tell here, dear students, you can see here it will become meter square. Okay, and this is again meter square. Meter square will be cancelled out with meter square. Okay. This, 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 this is the value of pressure given. The only change which we have made, we have in place of Pascal PA, we have used kilogram per meter second square. This. In place of PA, we have used this kilogram per meter second square. Okay. Kilogram per meter second square. This meter square will be cancelled out with this meter square. Okay. So, moreover, when we will keep mass on one side, then this second square which is in the denominator will become in the numerator and will be cancelled out with this second square. Okay. So we will get value of mass m equal to 5.268 into 10 raised to the power 18 kilogram. Okay. this meter square will be cancelled out with this meter square. Okay, this meter will become here. So actually, dear students, here 1 m stands for mass. Sallallahu alaihi wa sallam. Dear students, here I am removing some doubt which has appeared in the solution of this problem. Okay, actually, here all small m do not stand for meter. Okay, f is equal to mg. Now what we are going to do, we are going to replace it with capital M. Okay, because mass of the earth, now this capital M will not be cancelled with small m. Okay, we have to find out value of this capital M. Okay, this was a minor irregularity. Okay, kg per meter square into mg. This m is not smaller, this m is capital M. Okay, capital M, capital M, capital M, this into this. Here we replace 1 m with capital M. Okay, one M will be replaced by capital M. In this way, small m square will be cancelled out with small m, and capital M will remain on one side. Okay, so okay, this will become capital M. Okay, this, so this again. Okay, I think now it is quite clear. Actually, there was a minor irregularity, not a blunder, just irregularity. Here we cut, here we delete it, here we paste it. After pasting it, we enlarge this. Okay, now I think it is quite okay. So our solution has become mass of earth capital M equal to 5.268 into 10 raised to the power 18 kg. What, so what mistake was appearing in this problem before rectifying this mistake was that F is equal to mg. Here M stands for mass. M does not stand for meter. Okay. Here in place of Pascal we have used kilogram per meter second square. And here small m does not appear. It is capital M. It is mass. Okay. However, this is meter because radius is in meter square. Okay. So in the last, the M which will remain will not be small m, will be capital M. Okay, all other small m will be cancelled out, but F equal to mg, this capital M will remain until our last step, which will be the solution of our problem. Okay, and now I think this is the end of our problem. However, now we come towards the reference book from where this problem has been chosen. Reference book is Physics for Scientists and Engineers with Modern Physics. Authors are Raymond A. Survey, John W. Jude Jr. Its publisher is Cengage, and its 9th edition 2014 has been adopted or followed, and its chapter number 14 under title Fluid Mechanics is our concerned chapter, and this module is enumerated at serial number 4 of the exercise of this chapter, that is exercise number 14.4, and this is the end of our module. Okay.